Hello, my name is Andrew Nguyen, and I will be talking about finding solutions through a series of two equations in Unit 4. I will be explaining about one problem, which is xy equals 8 and y equals x squared subtract 10, and I will call xy equals 8a and y equals x squared subtract 10b for easier usage. And I will start using a and b as a substitute for this equation when I name them. So first of all, to start off finding the solutions we are trying to find are intersecting points of the two equations on a graph. To solve this algebraically, first get y alone in the A equation, which is by moving x to the other side by subtracting it to both sides. I got y equals negative x plus 8 as a result. And since y equals negative x plus 8 and y also equals to x squared subtract 10, I can conclude that negative x plus 8 equals x squared subtract 10. After that, move everything to one side by combining linear terms by plus x to both sides and subtracting 8 to both sides. And I got x squared plus x subtract 18 equals 0, which is a quadratic equation as a result. And continuing with this, we use the quadratic formula to solve this combined equation, and the quadratic formula is x equals negative b plus minus square root of b squared subtract 4ac divided by 2a, which to plug in a, b, and c into the quadratic formula to solve it. And a is 1, b is 1, and c is negative 18. And as I plug it in, I got x equals negative 1 plus minus square root of 1 squared subtract 4 times 1 times negative 18 divided by 2 times 1. And to solve the inside of the square root by multiplying, I end up getting 1 plus 72 inside the square root, and which also equals to the square root of 73, and which I got x equals negative 1 plus minus square root of 73 divided by 2, in which the square root of 73 equals 8.5, and I got x equals negative 1 plus minus 88.5 divided by 2, and which that equals to x equals 3.75, and x also equals to negative 4.75. So those are the x-axis points of the solutions, meaning that if there's two x values, there has to be two solutions or two intersecting points. So now to verify with a graph, I graph two equations separately. To graph y equals negative x plus 8, you graph it by slope because this equation is in slope-intercept form. And to graph y equals x squared subtract 10, graph using the quadratic formula to figure out the x-intercepts and to find the vertex using negative b divided by 2a. And this is the graph that I ended up with. And as you see, the blue line graph is y equals x squared subtract 10, and the red line graph is y equals negative x plus 8. And as you see, I was correct when there were two solutions when I solved them algebraically, where there's two intersecting points, one where the x is around negative 4.75 and the other is 3.75, as I am correct. So there are two solutions to this problem. So a relation to life for this problem is that many freeways intersect one another. Some may intersect, like in this problem. You would need to figure out the intersection points if you want to transfer from this freeway to another. Thank you.